Hello students, let us start our new chapter, motion in a plane. Motion in a plane. This is fourth chapter, and in this chapter we discuss about what is motion in a plane, that is introduction, and then what are scalars and vectors, and then what are the rules for addition, multiplication, subtraction, addition, subtraction, multiplication and division rules for vectors. And then we will study about resolution of a vector, and after that resolution of a vector, and after that we will study about the projectile motion, and then after this we will study about uniform circular motion or circular motion. Okay, so all these topics will have to discuss in this chapter. So let us start. Introduction about motion in a plane. So what are the need of scalar and vectors? We know that in previous chapter, if we see that there are only one dimensional motion possessed by object. It means all object possess the motion along a straight line, so they can move in only two direction, either in forward direction or in backward direction. So there are only two directions in which object can move. But if we talk about motion on a plane, that is, this is a plane. If we walk on this surface, then we have to more than two coordinates to specify. If we walk on this plane of the surface, then there are more than two directions in which we can move. If if any object moving in space, then there is also more than two directions in which that can move. So there are more than two directions in an object can move. So there are need of some particular position as respect to time, and also the direction in which the motion created by the object. If we talk about scalars, then scalars are those which possess only magnitudes. They have not any direction. They cannot possess any direction. If we talk more about scalars, if we take a rectangular field of length 1.0 meter and width 0.5 meter, then if we want to calculate the perimeter of this rectangular field, then what will be the perimeter? So perimeter of this rectangular field will be equal to 1 meter plus 0.5 meter plus 1.0 meter and 0.5 meter. So 1 plus 1, that is 2, and half that is 1. So 2 and 1, that is 3.0 meter. This is the perimeter of the rectangular field. So it is easily obtained by the directly summing up all the length and width of the rectangular field. Similarly, if we talk about another example like that, suppose that we have a cube, solid cube, suppose that of side 10 centimeter. A cube of side 10 centimeter. So if the side of this cube is 10 centimeter, then what will be the volume of this cube? Since the side is 10 centimeter, that is 0.1 meter, that can be also written as 10 to power minus 1 meter. So what will be the volume of this cube? This can be written as a side cube, that is 10 to power minus 1 cube meter cube. This will be equal to 10 to power minus 3 meter cube. How this volume of the cube can obtained by us? This can be easily obtained with the help of the product of the side. and we have not applied any different rule except ordinary algebra. So the physical quantities that needs for explanation are that are using the ordinary algebra for the calculation or explanation, they are possessed as scalar quantities. So similarly, if we talk about the temperature of the day, suppose that of the temperature of the day, higher temperature, that is 35.4 degrees centigrade, and the lower temperature of the day is 24.2 degrees centigrade, then what will be the total temperature difference of a day? That can be equal to temperature difference, that is T high minus T low, that is equal to 35.4 minus 24.2 degrees centigrade, that can be written as 11.2 degrees centigrade. So this temperature difference can be easily obtained with the help of the subtraction with ordinary algebra. So in this temperature calculation, the calculation of the temperature difference, we does not have any other special mathematics or any different special rule except ordinary algebra. So this is also a scalar quantity. This is the example for multiplication, this one is the for addition, this one is for the subtraction. So if you talk about another example in which we want to calculate a physical quantity that can be obtained with the help of the division of two different physical quantity. Suppose that the density of this cube, this is solid cube, if the mass of the cube is given, that is m kilogram, then volume of the cube is given as 10 to the power minus 3 meter cube. So what will be the suppose that the mass of this solid cube is 25.0 kilogram, 25.0 kilogram. Okay, so what will be the density of this solid cube? That is 25 divided by 10 to power minus 3, that is you can write it as what, 25 into 10 to power 3 kilogram per meter cube, that can be written as 2.5 into 10 to power 4 kilogram per meter cube. So from here we can easily guess what will be the total density of the cube. This density of the cube can obtained with the direct division of two different scalar quantity. So scalar quantity can obtain after the simple mathematical operation or ordinary after applying the ordinary algebra. So if we talk about vector, then vector needs some special mathematics that is known as vector algebra. They cannot be operate under simple algebra. Simple algebra cannot operate on vector quantity. So let us discuss about vector quantity. What are vector quantities? If we define vector, then we can say that vector is a vector quantity are those quantity which possess the magnitude and direction. Magnitude and direction. But these two are not sufficient for the definition of vector. Okay, so to define exactly the vector, we have another property that is known as the triangle law of addition. Triangle law of addition. Or equivalently, if we say that, parallelogram law of vector addition. Parallelogram law of addition. So the addition of vector cannot perform with ordinary algebra. There is a special need of vector algebra that can be defined with the help of two laws, that is one triangular law, or equivalently it can also be known as parallelogram law of addition. So the vector quantities are those quantities which have magnitude and direction but also possess the triangle law of addition or equivalently the parallelogram law of addition. So let us see what are the triangle law of addition and what are the parallelogram law of addition. Before knowing this, we have to know more about how a vector can represent. So a vector quantity can be represented by a bold letter. If there are bold letter V written as here, then this can be expressed as velocity vector. This is what? This is velocity vector. And if we write it as after mentioning the arrow on the V, this is the writing method to represent the velocity vector. Okay, this is also the velocity vector. In books, there are bold letters are used for the representation of vectors, but when we write in our copy or on the board, then we have not any bold marker, so we have to write a letter and mention a arrowhead on the letter. So this represents the vector quantity, and the vector quantity that possesses a magnitude and direction. So how the triangle law and vector triangle law and equivalently parallelogram law of addition applies on the two vector quantities. Let us see with the help of example. Suppose that this is a vector A that started any point O and ends at any point A. If we talk about another vector, that is vector B, that also started from O and ends at B, this quantity is denoted by vector B. So if we want to add these two physical quantities, vector A and vector B, then we have, but all of these two have the same nature. It does not, they are acceleration and they are velocity, then velocity cannot be added to acceleration directly. We know that in first chapter. In second chapter, units and measurement, we have discussed that only the same dimensional physical quantity can be added to each other or subtracted to each other. So if we want to add these two physical quantities, so the dimension of these two will always be same. So if this is force, then this will be also force. This is acceleration, then this will be also acceleration. If this is velocity, then this will be also velocity, and so on. If this is displacement vector, then this will be also displacement vector, and so on. So if we want to apply the triangle law of vector addition, then we have to first draw the first vector, vector A, starting from any point O and ends at any point A. Then if we want to apply triangle law, then we have to draw the second vector, that is OB, starting from A and drawing in same direction. Further, we have discussed equal vectors. We know that if two vectors are equal in magnitude and also same in direction or parallel in direction, so they are treated as equal vectors. So if we draw this vector by starting from A and just along the direction of OB, and this vector is treated as vector B. So if we join, this point is B, if we join a line from the tail of the, this is tail and this is the head of first vector, and this one is the head of the second vector, this one is the tail of the second vector. So if we draw a line starting from the tail of first vector to the head of the second vector, then this line indicates the vector sum of these two vectors, that is vector A plus vector B. Okay, but in algebra, in ordinary algebra, if we find out the value of A is 3 and the value of B is 4, then the value of OA plus OB equal to 3 plus 4, that is 7. But in vector algebra, this will be not equal to 7 because they can be added by vector addition method, and the vector sum of these two vector will be the length of the line starting from O to B. So by measuring the length of this line, we can write what will be the vector sum of these two physical quantity. Okay, so this is all about vector and different methods, that is triangle law. Also if we talk about a parallelogram law, then mention here, if two vectors are co-initial vector, that is vector A, vector B originating from any point O, then if we form a parallelogram with the help of these two vectors, so we have to draw vector B starting from A, head of the A, and we have to also draw another vector A that can started from the head of the B. So this is a parallelogram. So this vector can be treated as vector B, and this one also be treated as vector A because they have equal magnitude and also same direction, and these two also have the same magnitude and same direction. So these two vectors B and B are equal vectors, and these two A and A are also equal vectors. So what will be the total resultant of the sum of these two vectors? So this will be provided with the help of a line, a diagonal of the parallelogram starting from the co-initial point. This point is the co-initial point of both vector A and vector B. So if we draw a line starting from vector the co-initial point to the head of these two vectors, are interaction of these two vector point. Okay, so the direction of the line joining from the co-initial point to the joining point provides the total vector sum of these two vector A and vector B. Okay, this is known as parallelogram law. So a vector quantity always follow the rule, first what they have magnitude, and second they have direction, and also they follow what? They follow the triangle law of addition, or equivalently we can say that what? Parallelogram law of addition. Okay, so this is the definition of vector. There are different types of vector: displacement vector, position vector, equal vector, unequal vector, opposite vector, perpendicular vector. So all these types of vector has already mentioned in my earlier video. I will send the link of this earlier video in this video. You can see that lecture. So let us start our discussion about displacement or distance, displacement or position vector. Okay, so let us start our discussion first about position vector. What is position vector? We know that if any object has to define in three-dimensional space or in two-dimensional space, suppose that if you talk about a plane, then this is a plane of the board, then this plane of the board can be represented at the any point of the plane of board, so can be expressed with the help of a simple frame of reference or coordinate system. So they can be represented by x and y axis. Suppose that they are intersecting each other at any point O, then any point on the plane of this board, suppose that this point is P, then what will be the position vector of this point P? So if we join these this point P from the O, then the line joining from O to P provides the position vector of point P with respect to this origin point. Okay, this is the position vector. This is the position vector of this point P with respect to the origin. So if we talk about another point, suppose that P dash, so what will be the position vector of this point? This will be equal to or this can be represented with the help of a straight line joining from O to P dash. Okay, so suppose that vector OP is vector R1 and vector OP dash is vector R2. So all these vector R1 and vector R2 are the two position vectors of two different points in the plane of the board. So let us talk about displacement vector. Displacement vector. So this can be explained easily as suppose that any object which is placed at any point P at any time T, and after some time at any time T dash it reached at any point P dash. By taking some hot path, they can go from P to P dash by this track, via this track or the straight line. They can follow different paths, but at any time T, if the object possesses at any point P whose position vector is R1, and at a time T dash the object must reach at point P dash whose position vector is R2. So what displacement created by the object? So if we talk about the displacement created by the object, and since object moves from point P to point P dash, so if we join these 2 points with a straight line started from P and ends at P dash, then the straight line joining from P to P dash provides us the displacement of the particle or object from point P to P dash. So this straight line with direction provides the displacement vector created by that object, the displacement created by that object in time. What? How much time? T dash minus T. So in time T dash minus T second, the object must create a displacement vector P dash. So this vector P dash can be obtained in terms of R1 and R2 by simple vector algebra. As we know that if we take this OP as first vector and PP dash as second vector, then this OP is started from point O and PP dash is started from point P. So if we join from O to P, then the line joining from the tail of the first vector, this one is the first vector and this one is the second vector. This first vector is R1 and this one is the second vector that can started from the head of the first vector. So if we join a line straight from the tail of the first vector to the head of the second vector, then must be equal to, then this R2 must be equal to R1 plus PP dash, R1 plus PP dash. Okay, so what will be the value of PP dash, that is displacement vector, that can be equal to vector R2 minus vector R1. So this can be written as vector R2 minus vector R1. So the vector R2 minus vector R1 can be expressed as the displacement vector. Okay, so this is all about the displacement vector, position vector, and vector quantity, triangle law, and parallelogram law. So let us come to next topic, that is resolution of a vector. Resolution of a vector. What do we mean by resolution of a vector? Suppose that we have a vector in a plane and we want to express that vector in two different position coordinate, that is, suppose that this is x-axis and this one is the y-axis. So resolution of a vector, resolution of a vector. Suppose that here is a point P whose position vector is R. So if we want to resolve this vector R in the terms of x and y, so if we want to know what is the position coordinate of this point P, then if we draw a perpendicular on x-axis and the length on x-axis of this perpendicular from origin is x, then and the perpendicular drawn on y-axis and the perpendicular distance from origin to this line is y, then the position coordinate of this point can be expressed as x and x comma y. Okay, so suppose that this x and y is the distance along the x-axis and also along y-axis. So this x contains a direction, suppose that I cap, and if the y contains a direction, that is j cap. So we want to express this vector r in terms of xi and yj. So this can be expressed easily with the help of, suppose that the direction of x-axis is taken as I cap, so the distance from O to this point A is taken as what? If we represent this with the help of a vector, then this vector OA can be written as what? The distance of length of this vector, that is x, and direction of this vector. Because a vector can be expressed as the product of the magnitude and direction, so this vector OA can be expressed as xi. And also, what will be the value of this vector OY? So the length of this vector is OY. Suppose that this point is B, OB is equal to length of the vector is y and direction of the vector is j, so length of the vector OB will be equal to yj cap. So by the definition of equal vector, if we take this AP, vector AP, then this vector AP will be just equal to the vector OB, because the definition of equal vector, they are in same in magnitude and in same direction. So vector OB will be also equal to vector OP. So if we want to know what will be the value of this vector R in terms of x and y, then what will be the value of this R? As if we apply the triangle law of addition, then we find out, suppose that vector OA is the first vector and this one is the tail of the first vector and this is the head of the first vector, and if we start the second vector from the head of the first vector, then this can be treated as second vector which can be started from the head of the first vector. So what will be the resultant of the sum of these two vectors? That will be equal to and that can be represented by a simple line that joins from the tail of first vector to the head of the second vector, that is vector R. So that vector R can be expressed as vector OA plus vector AP, vector OA plus vector OP, and we know that vector OP is equal to vector OB, so this will be equal to xi cap plus yj cap. So this is a vector R that can be resolved along x and y component of the coordinate. Okay, so this is a planar coordinate x and y of any point with respect to O, that is origin. So a position vector of this point with respect to O can be expressed in the position coordinate. Okay, this is a simple resolution of a planar vector. So if we talk about a spatial vector, it means three-dimensional vector. So that can be further expressed as xi plus yj plus z cap. Suppose that the direction of the z axis represented by k. Similarly, so the position vector of any spatial point, so that can be expressed in their rectangular component, that is xi plus yj plus z k cap. Okay, this is the three-dimensional resolution of a spatial vector. So this is all about the resolution of a vector. Okay, now come to a simple rule that is also known as resultant of two vectors. resultant of two vectors. Suppose that we have two vector A and vector B. So if we take the direction or the inclination of vector B with respect to A is theta, then what will be the resultant of these two vectors? We can easily obtain the resultant of these two vectors with the help of forming a parallelogram and with the help of a line joining from the co-originating vector to the co-joining vector. Okay, this is the resultant of these two vectors. Suppose that this vector is R. So R can be expressed as what? R can be expressed as vector A plus vector B. Okay, this is the vector A and this will be the vector B. And we know that any vector that can be expressed as the product of the magnitude and direction. Vector B can be expressed as the product of the magnitude and direction. So if we draw a perpendicular and elongate the line OA in forward direction, then we get what? Suppose that this point is B, this is the P and this one is the C. So we are seeing that this is the direction of first vector and this one is the direction of second vector, and we have earlier taken as the angle between these two vectors is theta, so this angle can be taken as theta, and this is the perpendicular on this line, so this angle is 90 degree, and the line AP will treated as the hypotenuse as for this triangle ACP, because this is a right angle triangle. So for this angle theta and this one is the 90, AP is treated as hypotenuse, AC is the base and PC is the perpendicular. So what will be the value of perpendicular? As we know that perpendicular upon hypotenuse is equal to sine of theta, so perpendicular equal to hypotenuse sine theta, that is B sine theta. This is the length of PC. And what will be the length of AC? This is the base for this triangle. So base upon hypotenuse equal to cos of theta. So base equal to hypotenuse cos theta, that is B cos theta. Okay, so total length of OC will be equal to length of OA, that is A, plus length of AC, that is B cos theta. So this is the total length of OC. If we apply a Pythagoras rule in right angle triangle OCP, as in this triangle vector R is seen, that is length of OP can be taken as R, because this vector can further expressed as the product of magnitude and direction. So length of vector OP is R and direction of OP is R cap. So if we take a Pythagoras rule in right angle triangle OCP, write it as OCP. So in this triangle, the square of the hypotenuse, that is R square, is equal to the perpendicular square plus base square. So B sine theta whole square plus A plus B cos theta whole square. So this will be equal to B square sine square theta plus A square B square cos square theta plus A square A square plus B square cos square theta plus 2AB cos of theta. So if we take B square common from these two terms, then from here sin square theta plus cos square theta, that becomes 1. So from here A square and from here to B square plus from here 2AB cos of theta. This is the value of R square. So value of R is equal to under root A square plus B square plus 2AB cos theta. So with the help of this formula, we can easily obtain what will be the magnitude of the resultant of two vectors, vector A and vector B. So the resultant of these two vector R that is vector r equal to vector a plus b, then the magnitude of this vector can be expressed as the under root of the magnitude square of the square of the magnitude of first vector plus square of the magnitude of second vector plus twice of the product of magnitude of both vector multiplied by the cosine of the angle between both vectors. So this is the simple resultant of two vector, magnitude of the resultant. And what will be the direction of this resultant? This resultants, suppose that this resultants make an angle alpha with the direction of first vector, vector A. If we assume that this resultant vector makes an angle alpha with the direction of the first vector, then what? Then we can easily obtain the value of alpha that provides the direction of resultant. So if we apply the tan of alpha in triangle OCP, then tan of alpha will be equal to perpendicular upon base. Perpendicular means B sin theta divided by base, that is a plus b cos theta. A plus b cos theta. So from here we can write it as alpha equal to tan inverse b sin theta divided by a plus b cos theta. From here we can easily obtain what will be the value of the inclination or the direction of the resultant with respect to the first vector. Similarly, we can obtain the direction of resultant with respect to the second vector, because they are inclined to each other by an angle of theta. So this one is alpha, then this becomes theta minus alpha. So after obtaining alpha, we can easily obtain what will be the value of theta minus alpha, that is direction of resultant with respect to the second vector. So this is all about the resultant of two vectors. Okay, today we will discuss all these topics. Tomorrow we will discuss further remaining part of this chapter. Till now, thank you.